Hi guys, just before we start this video, I'll just mention this is part 2 of this project if you didn't see the part 1 which I published about 3 weeks ago. So in part 1 we actually constructed the MilliOhm meter, we tested it and found it wasn't working. And I published that video under the title Help, My DIY Project Doesn't Work. So in that video at the end we did a few measurements, some tests, we figured out what was wrong with it. I was waiting for the correct parts to arrive and now they're here. So if you haven't watched part 1, I suggest you watch that first. I'm going to put the link in the description to this video so you can find it easily. If you did watch that, then you can just carry on where we left off. So we're now going to fit the replacement parts and we're going to test the MilliOhm meter in this video. Hope you enjoy it guys, here it comes. Welcome to another Learning Electronics Repair video. This video is kindly sponsored by PCBWay and we're looking at the MilliOhm Meter Project. I'll show you the project on PCBWay's website and then we can do some more work on ours. PCBWay make a whole range of PCBs suitable for designers, prototyping, small production runs, and they can also build the entire project for you, the entire device that you have designed, populated with all the components, or they can make you the PCBs and a number of other services. They make 3D printed enclosures and similar. But a great thing I found with PCBWay is the shared projects area. So these are projects that people have uploaded. You can upload your own projects here, the schematics, the layout, the Gerber files. You can order the PCBs directly from the project from PCBWay or the completed device in any quantity that you like, and whoever uploaded it gets a commission from that. So it's a great way to share your projects. And we've had a look at a few before, but in particular we were looking at the MilliOhm meter. This is the MilliOhm meter completed. And previously I ordered some PCBs from PCBWay, which I can just show you now, and I constructed the project only to find it wasn't working. I made a great video on this, which I'll link from this one, and at the end of the video basically figured out the problem was due to a substitution of an original component which I didn't have, and the internet, Google told me another component was compatible, and in fact it wasn't. So let's continue from that point. I have the correct parts now and I'm sure we can get our MilliOhm meter working, and let's test it and see how good it is. These are the PCBs that PCBWay sent me. They come in a minimum order quantity of a pack of 5. Cost me $5 or €5 plus the postage. And I actually used the schematics from the project on PCBWay and I built one of the devices. This is this one. So we have it here now. If you watch the first half of this video, you'll know that I put 741 op amps into the project because I had some in stock and because Google told me they were a suitable replacement or compatible with the original ones, which are the OP07 op amps. And basically we found that isn't the case. There's two of them. One of them is a constant current generator which sends 100 milliamps into the resistor you want to measure, or the device under test you want to measure the resistance, and that worked. The other one, which actually measures the resistance on the meter here, didn't work, and it's because the OP07 has some features that the 741 doesn't have or implements in a different way. So I've put the correct op amps in now. Previously it wouldn't zero at all. Let's see what happens now. So we'll put the two probes together, get a connection, and it basically zeros. Okay, let's see how stable it is. Well, it takes a little bit of time, it's settling down, but it's getting close to zero. And we have a little trimmer pot here, which should be a multi-turn pot, but I fitted ordinary ones, and this adjusts it. So yeah, you can see I can turn that down, and I can set it to 0. A little bit more. No, it's on. It's zeroed. So we can now zero the MilliOhm meter. That's great. We couldn't do that before. I'm using two SMD tweezers. If you didn't see the previous video, I've effectively soldered the ends together, and I'm using them as Kelvin probes. I modified them so one has two black leads and the other one has two red leads, yeah? And then they just kept next to the red and black current and voltage sense on the board. So we have it working. On the first part, I measured the voltage across this resistor, which is part of the constant current, 10 ohm resistor, and adjusted it using the voltage effectively to set the current. But I don't know how accurate that is because this is a 5% resistor. So what I'm going to do now is see if I can set the current to 100 milliamps between the two probes. And I'm just going to do this using my multimeter on current range. So to calibrate this, as I say, I'm going to use the multimeter on amps range. So we'll go to amps. This is auto ranging milliamps amps. You can see it there. I'm not sure if I put the light on it will help you see it any better, but yeah, maybe it will. So I'm going to use crocodile clip leads to attach these to the test probes, which means I can more easily adjust it. The resistance of the lead shouldn't really make any difference because this is a constant current source. So let's try attaching. We have the black homemade Kelvin probe. Go to the black meter probe. And we have the red one going to the red meter probe. Let's see what we have. We have 102.2. Make sure when you do this, by the way, you set your cables correct for amps, yeah, into the correct sockets, yeah. Obvious thing, but mistakes happen. So let's see now. Let's see if we can adjust the current. Now, obviously I got it close by measuring the voltage drop across this resistor and using Ohm's law. But because of the 5% tolerance of the resistor, you can see I was about 2% out. This should be a multi-turn pot, and I didn't fit them, I didn't have them, although I do need to order some. So let's see if I can adjust it successfully. Well, it's going up, so I'm on a normal potentiometer. But with a little bit of careful adjustment, I can probably get it. Yeah, 100 exactly. So we now have 100 milliamp. This is a good opportunity to test how warm the MOSFET gets. And it's warm, but you can comfortably put your finger on it. So that's not going to overheat with a little heatsink I fitted. So let's see now how well this works measuring resistances. I think the best way to do it is going to be to compare it with the VC480 plus MilliOhm meter I have. I don't know how accurate that is either. I don't have any reference quality resistors, but let's try and let's see at least if this reads very similar to the commercial MilliOhm meter that I have. I have some resistors here we can test, so we'll just measure these first and then we'll compare with the commercial meter as I mentioned, and we'll see what it's like. So let's just see first if this is basically working. So I'll connect to this. This is a 0.5 ohm resistor. What's it read? Well, it reads 0.502. Just has to set a little bit. I notice there's a little bit of a settling time, this. Well, actually, that's reading basically 0.5. Yeah. I mean, I don't know how accurate this resistor is, but let's make a note of that one. And we'll check the other ones as well and see what they read. Okay, I've noted that down. Let's try this one. So this is a 0.22, so this is a lower value. What's this read? Again, I'll let it settle down a little bit. Wait till it stops changing, I think. Okay, I think we're kind of there now. So 0.2180. We'll make a note of that. And then let's try the lowest resistance, which is this one. 0.05. What's this read? Again, let it settle down a little bit. Yeah, we seem to be there. So 0.0503. Okay, that's the three resistors I'm going to try. Let's have a look at the VC480 now with the commercial Kelvin probes on, not my jury rigged ones. And let's see what that reads. Here it is then. So first of all, we'll switch it on and let's zero it. So we'll put it onto the 2 ohms range because that's going to read the 0.5. So we're on the 2 ohms range. Just put the two probes together. Let's make sure it's zeroed. It's zeroed, okay. So our 0.5 ohm resistor, what's it read? Well, it actually reads 0.502. How does that compare with our PCBWay project? Well, you can see it compares very favourably. So that's 0.502 ohms. Okay, let's look at the next one. Well, that actually reads 0.218. Okay, our little PCBWay gave us the same with an extra decimal point. 0.0218. Okay, and the last one. Now we can actually go down 0.05. I'll just switch the range now. Let's make sure this is still 0 correctly. No, we have to readjust this to set the range you're on, something we didn't have to do on the PCBWay. And that's actually reading in milliohms, so we need to effectively put the multiplier in. So that's actually giving us 0.0484. Okay, 0.0484. We can compare that then with the PCBWay project. And there we have it. So what we can say, we obviously don't have a reference, but we can say for sure is that the commercial MilliOhm meter and our very inexpensive project MilliOhm meter are reading very, very similar, especially on these two. I mean, I think that is damn impressive, I think. I mean, we do know that the resistance is the same on when we measured on both meters, so that, in my opinion, is very accurate, and I don't actually know which of the 2 meters is the most accurate. But I would have to say they basically give me the same reading. And that, my friends, I think is really impressive. I'm very impressed with this little device. So what do we need to do to finish it off? Well, the main thing we have to do is to sort out some sort of power supply, because I'm at the moment running it from my bench power supply plus and minus 12 volts. I don't have any little plus and minus volt supply to hand. So let's have a look to see what we can find. And the first place I'm going to have a look is back on PCBWay. I'm sure they have lots of PSU projects, so let's have a look to see what they actually have. So we're back to PCBWay. Let's have a look in the DIY community again. And under the various topics, do we have a separate one for power supplies? View all categories. Well, we certainly have a lot of different headings, and they appear to be in alphabetical order anyway, so I'm sure we can find what we're looking for. But let's just make sure it's not listed in some other way. Power supply. I think there's a very good chance of finding what we're looking for here. Obviously we can upload our own projects, but let's see what we can find that other people have done. Okay, so we now have the various projects. There's many of them, so I'm going to have a look through and let me see if I can find any dual output power supplies. I've had a look through and there's a couple of projects that seem the most interesting and useful to complete our MilliOhm meter. One of them is this project, which uses a linear transformer. So a centre tap transformer, 15015, something like that. I guess the maximum voltage would depend on the regulator it's using. So this is using LM317, 337. I think they can handle up to about 30 volts or so input anyway. So a 24024, 15015, 18018, something like that would be fine. And we could use this. This I think can supply about 1 amp per output. I haven't looked exactly at it at the moment. But we could go down this route. And if I can find a scrap device with a linear centre tap transformer, this would be quite cheap to build. The other one that caught my eye is maybe a bit more interesting. So this is actually a switch mode power supply. It's giving plus and minus 35 output, but I suspect we could probably modify this to get what we want out of it. And this is using effectively salvage parts from an ATX power supply, which you then have to rewind, which could be rather fun. I think we could learn some interesting skills. So there is this project. If I can find enough information about it, maybe we can look at this one as well. The last thing that caught my eye is nothing to do with this project, but was interesting, I thought. And that's this. So this is a 1000 watt 220 volt inverter from a 12 volt power supply. I thought this might be interesting, A, because I know quite a few of you guys are interested in inverters, and B, this might be a useful way to produce an isolated mains power supply on your bench for testing devices under test. And because it's isolated, you can connect your oscilloscope ground to the hot ground on a power supply, for instance, and not come to any harm, nor will your oscilloscope. So that project, although it's not directly related, I thought might be interesting. So I'd like to know what you guys think, actually. Well, guys, I have to say we had a result there. This worked far better than I ever expected it to do. There's a few things we can do with this. One is obviously to complete the project. So we need to build this into a little case, maybe get Carlos involved with his 3D printing, or I might just salvage something, you know, an old satellite receiver or something. I'll see what I can find. The second one is that we need to build or buy or find some sort of dual power supply. This runs on plus and minus 12 volts, but we can use something a little bit higher and then use a voltage regulator to get the voltage we want. I believe the voltage is probably important, that it's stable for this to work properly. So we have that to do. Now I've found, as you've just seen, a few interesting projects on PCBWay. I'll link them all in the description to this video, so I'm inviting you guys to have a look through to see or suggest what you'd like me to build. I've got a funny idea. I know exactly what it's going to be before I even ask. Let's see. I know what you guys are going to say. Anyway, you can suggest what I kind of dread building, or you can suggest something else, and that probably told you anyway. And we can get into that. We can order. We have the sponsorship deal with PCBWay. We can order some PCBs, and we can do. If you have any other suggestions of how to get the plus and minus 15 or 12. I mean, I do know on AliExpress there are little DC to DC converters that will give you a positive and negative supply from just a DC coming in, sort of 5 volts, 12 volts in, and plus and minus 12 or whatever you want, adjustable. And we could buy something like that, but it's not half as much fun as what we're looking at here, I don't think. But hey, you know, let's talk about it. And then when we got it all put together in the part 3, I want to have a play with this again. So this is the Learn Electronics Repair Retro Upgrade Joint Project. This is the upgraded version of the $1 short finder. I now have all the components here to build these. I'm going to modify the casing to use, instead of like AAA batteries, some sort of like CR2032 or something like that battery. See how small we can make this thing to fit onto your multimeter. But we have the original design, we have the original enclosure, so we can put that together as well. This will fit to the back of your multimeter, allow you then to connect your Kelvin probes to your multimeter. You set it to millivolts range, and depending on the resolution of your meter, effectively 1 microvolt is equivalent of 20 microohms. That's the resolution of that one. So we'll do that all together, and then we will compare this, which actually measures the resistance, with this, which is a short finder, actually on some circuits boards. We know this measures resistance and this doesn't, but what we could like to see, and I would like to see, is how well this works as a short finder compared to this one. But hey, you know, horses for courses, and I suspect, in all honesty, both projects are worth building, well worth building. So it's the weekend, guys. We can leave that one there. Lots of things to think about. Hope you enjoyed this video anyway. I'd like you to get involved in it, and let's see what we can do with it. And I will see you all soon on another linear electronics repair video. Ciao for now, guys.